Welcome students to Pradeep sir classes as BSc where logo can talk the physics. And today we are in IIT Foundation course, that is ICSE-10, and obviously this is work power energy lecture number 5 and chapter number 2. And students, if you are first in that class, obviously then go back to the previous one from lecture number 1 to 4 and then again join. Okay, so that will be a proper order. So next, what is our goals and what you are able to understand for that particular class. So this is first of all students, this is energy. What is energy? And the next one is the unit of energy, and obviously this is watt hour and the kilowatt hour, and the different what is the unit of, basically what is the unit of heat energy, that is calorie and calorie, and what is the relationship between the calorie and joule, and then electron volt, that is what is the energy possessed by a atomic particle. Okay, obviously this is definition, and the last of all students, what is the difference between energy and power. So let's start with what is energy. So somehow students, when you do some work, you want to shift a sofa coach, you want to shift a almirah, you want to shift, suppose it is at least a particular book from one shelf to another. Okay, so somehow you are doing some work, then you feel that your energy decreases. So you know that from that particular experiment, that particular example, that particular daily life, that somehow work is related with energy. So what is the relationship between the work and energy? When a body do some work, then its energy decreases, you know that. And when, if we do some work on a particular system, then we can say that its energy increases. So when energy increases, when energy decreases. And so what is the definition? First of all students, write down the definition. And what is the definition? The energy of a body is its capacity. Okay, so what is energy? So first of all students, write down a question: what is energy? What is energy? Or you can easily write down defined energy. What is the definition of it? So energy is the ability to do work. Simply we can write as energy is the ability to do work. So capacity of doing work, that is, we can say that when a body is capable of doing work, when a body is capable by doing work, when a body is capable of doing work, then we can say that the body possesses some energy. So when a body is capable of doing work, it has the capacity to do work, then we can say that the body possesses some energy. So work is somehow interconnected with energy, and that is energy, and it is a, which quantity is it? So it is a scalar quantity. When there are different physical quantities which possesses only magnitude, then we can say that this is a scalar, and which possesses magnitude as well as direction, then we can say that it is a vector quantity. So energy is possesses only magnitude. So we can say that this is a scalar quantity. So energy, the next one is energy is a scalar quantity. So which quantity is it? We can say that energy is a scalar quantity. What is energy? It is the capability, it is the capacity to do work. And the next one is, what is the unit of energy? What is the unit of energy? We can say that the unit is energy, that is the unit of work done. So first of all, SI unit of energy is joule, and joule equal to, so joule equal to 1 joule equal to 1 Newton meter, 1 Newton and 1 meter. So Newton means 10 to the power of 5 dyne, and 1 meter means 100 centimeter. So this is 10 to the power of 5 and then 2, there is 7 dyne centimeter, or 10 to the power of 7 arc. So joule is the SI unit and arc is the CGS. So CGS unit of energy equal to arc. So the SI unit of energy is joule, and 1 joule is somehow interconnected with arc, that is 10 to the power of 7 arc, and Newton means 10 to the power of 5 dyne into 1 meter means 100 centimeter. So 5 and then 2, that is 10 to the power of 7 dyne centimeter, or you can say that 10 to the power of 7 arc. Okay. So the next one is watt hour. What is watt hour? And all the unit interrelated with, that is watt hour or kilowatt hour, you have to always convert it into joule, that is SI unit of energy. So watt hour. So what is the definition of it? Watt hour. So you can easily say that 1 watt into 1 hour. So when if the energy of a machine, we can say that the energy of a machine is 1 watt hour, when it consumes, it is spent a power of 1 watt in 1 hour. It is spent a power of 1 watt in 1 hour. Then we can say that the energy of the machine is 1 watt hour. So 1 watt mean 1 watt into 1 hour. Watt means joule by power equal to joule by second. So this is joule by second into 3600 second. So second and second cancel, and we can say that 3600 joule, or if we divided this with 1000, then we get, and this is kilojoule, or 0000, that is 3.6 kilojoule. So 1 watt hour, and this is equivalent to 3.6 kilojoule. Okay, so this is the conversion of this particular energy, unit of energy, into SI unit of work, what? Joule, that is kilojoule. So you can say that 1 watt hour equal to 3.6 kilojoule. And the next one is kilowatt hour. So kilowatt hour, again we can say that a kilowatt hour watt and hour, that is it spends a power of 1 kilowatt in 1 hour. It is a machine, but a machine that spends a power of 1 kilowatt in 1 hour, then we can say that the energy of the machine is 1 kilowatt hour, or the instrument, that particular devices can consume this amount of energy when it spends a power of this in 1 hour. Mainly we can say that this is a board of trade unit, or it is board of trade unit, BOTU, BOTU. What is board of trade unit? That is 1 kilowatt hour, or 1 unit of current. 1 unit current. Current means energy. 1 unit consumption of electricity. 1 unit consumption of electricity. That is 1 unit current. Normally we can say that. So it is a board of trade unit. Basically it is a board of trade unit. Okay, so 1 kilowatt hour, it spends a power of 1 kilowatt in 1 hour. So kilo means 1 kilowatt hour. This is 1 kilo means 1000 watt, and this is 3600 second. 3600 second. So watt means joule by second. So in place of watt you can write that joule by second, and second cancel this one. So 3600000. So 3.6, and if you shift a 6 division, take 6 digit, then you can say 10 to the power of 6. Okay, so 3.6 into 10 to the power of 1, 2, 3, 4, 5, 6, and this joule. Or easily you can say that 3.6 mj, megajoule. Okay, so 3.6 megajoule, 1 kilowatt hour is equivalent to 3.6 megajoule, and 1 kilowatt is equivalent to 3.6 kilojoule. Kilojoule, megajoule, it is a large unit that is used for energy consumption rate. Okay, then basically heat energy is always converted into some energy. Energy cannot be created nor be destroyed. It is somehow transferred. So energy transformation is always interconnected. So when you do some work, then your work is converted into heat, and obviously you have to know what is the SI unit of heat. So SI or CGS, it may be a calorie is a measurement of particular heat energy. Heat energy. So it is, heat is also energy. Heat energy. So the next concept is heat energy, and the unit of it is calorie. Calorie. So 1 calorie is the amount of heat required. 1 calorie is the amount of heat energy required to increases a temperature of 1 gram of water through 1 degree centigrade. We'll discuss with that particular calorie in a larger concept, in a vast concept, when we study with calorimetry. Okay, so this is for that. And if you specify, since water is related with anomalous behavior, that is within the 4 degree centigrade, so you can specify that particular value 14.5 degree centigrade to 15.5 degree centigrade. That is also a 1 degree. So easily you can say that 1 calorie is the amount of heat energy required to increase the temperature of 1 gram of water through 1 degree centigrade, or in place of 1 degree you can write 14.5 degree to 15.5 degree. 14.5 degree to 15.5 degree, that is through 1 degree centigrade. Okay, so this is the definition of calorie, and you can memorize that particular value. 1 calorie equal to 4.18 joule. Okay, so 1 calorie is equivalent to 4.18 joule, that is approximate, you can take as 4.2 joule, or 1 joule equal to 0.24 calorie. Okay, so this is the relation connecting all the unit of energy. We are basically converted into joule, that is the SI unit of energy. Okay, so the next one is the calorie, and this is the definition, and the atomic particle, energy of the atomic particle. As students, you can easily check out that we are discussing with different types of energy, unit of different types of energy that are interconnected with particular specific physical quantity. So atomic size, atomic particle, energy of the atomic particle, energy of the atomic particle, atomic particle, energy of the atomic particle, that is electron volt. 1 electron volt equal to 1 electron into 1 volt, that is 1 electron means 1.6 into 10 to the power of minus 19 coulomb into 1 volt, and coulomb and volt, this is equal to joule. So 10 to the power minus 19 joule. You can memorize this one, V equal to W by Q. So work done is potential into charge. When coulomb is the unit of charge and V means potential, so work done equal to this into this. So coulomb into volt means joule. So 1.6 into 10 to the power minus 19 joule, and energy of the atomic particle is electron volt. And you can also write down the definition of electron volt. So electron volt, what is the definition of it? So electron volt is the energy, electron volt or simply small e and capital V. Electron volt is the energy, possessed by an electron, when it accelerated through a potential difference, and you can simply write as PD, potential difference of 1 volt. So electron volt is the energy of the atomic particle, and the energy, electron volt is the energy possessed by an electron when it accelerated through a potential difference of 1 volt. So students, there is a potential difference, and electron is moving from, suppose it is a low potential to high potential, electron is moving, so that the energy possessed by that particular electron is taken as electron volt unit, and the electron volt is equivalent to 1.6 into 10 to the power minus 19 joule. So this is the definition of electron volt, and last of all students, I discussed with the difference between the energy and the power. So the next topic is, what is the difference between energy and power? So energy and this is power. students, it is so simple one. So energy is the ability to do work. Energy is the ability. Energy is the ability to do work. To do work. Energy is the ability to do work. And power, how fast it is. How fast it is. So it is the capacity to doing work. So power is the power equal to, we know that work done by time. So work done by time. How fast you can do some work. Okay. So power of a source is the energy spent. Energy spent. So work is somehow related with energy. So power equal to energy spent. Energy spent in 1 second. This is called power. And it doesn't depend on time, but it is depend on time. And the third one is energy. Its unit is joule, but its unit is joule by second, that is watt. So these are the basic information we can give them, that is the energy and power. What is the difference between energy and power? So students, I think you enjoyed the particular lecture, and there is what is work done, what is the energy, and for today's basically class mainly it is about energy and what is energy, how work and energy are related, and the different units we used in the particular numericals. And the next one is what is the difference between energy and how you can measure the energy of the atomic sizes, that is electron volt. And I think students you enjoyed the class, and if you want, this is best concepts and this is the best deliver of that particular lectures, and you realize that particular lectures with from your heart, then you can easily subscribe and share this channel with your friends. Okay, so thank you, and last of all, continue with the study. Okay, bye.